Learning target 6.3 says I can identify empirical formulas for compounds. So the empirical formula is the simplest ratio. Alright, so if we look at a table and compare molecular formula to empirical formula, let's say we look at benzene, C6H6. The 6 to 6 ratio will reduce to 1 to 1. So our empirical formula is CH. If we look at glucose, C6H12O6, this ratio will reduce to 1 to 2 to 1, making our empirical formula CH2O. Pb2O4, 2 to 4 reduces to 1 to 2, so your empirical formula would be PbO2. So the empirical formula is just the simplest ratio of your atoms to each other. So learning target 6.4, we're going to write empirical formulas using the mole ratios. We're going to actually calculate mole ratios by doing mole conversions. So here's an example problem. The empirical formula of a compound containing 1.67 grams of cerium and 4.54 grams of iodine. So we need mole ratios. What do we have in this problem that we can convert to moles? Well, we have grams. We can use the molar mass and convert from grams to moles. So 1.67 grams of cerium is equal to 0.0119 moles of cerium, and 4.54 grams of iodine is 0.0358 moles of iodine. So our ratio is 0.0119 to 0.0358. So if we put that in a formula, it looks like this. Now, you guys know we cannot leave this. We have to have whole numbers. So how do we make it become a whole number ratio? The easiest way to do that is to divide each one of your moles by the smallest number of moles. Alright, this is going to give a 1 for the smallest. So 0.0119 is the smallest. So for iodine, if we divide by itself, we get a 1. I'm sorry, for cerium. For iodine, 0.0358 divided by 0.0119, we get 3. So 0.0119 to 0.0358 is a 1 to 3 mole ratio. So we can put that into our formula as our subscripts, and our formula becomes CeI3. Here's another problem. Calculate the empirical formula of Freon. Now, we have percentages here. So the easiest way to take care of the percentage is to assume that we have a 100 gram sample. Doesn't matter how much we have because they're all going to have the same percentage. So if we say we have 100 grams, then all the percents become grams because 9.93% of 100 is 9.93 grams. So your problem easily transforms this way. So just change those percent signs to grams. Now we find moles. So we use the molar mass for carbon, and we find the moles of carbon. Do the same for chlorine using its molar mass. Do the same for fluorine using its molar mass. So the smallest number of moles here is 0.0268 moles of carbon. Now notice I did carry this out a good bit. You want at least 3 numbers after the decimal. So we're going to divide each one by our smallest, which is our 0.8268. So that's going to give us a ratio of 1 carbon to 2 chlorine to 2 fluorine. So our formula is CCl2F2. One more example. We're going to find the empirical formula for benzoic acid. Now again, we have percentages here, so simply assume a 100 gram sample and change those to grams. So for carbon, we get 5.729 moles. For hydrogen, we get 4.911 moles. And for oxygen, we get 1.6375 moles. So 1.6375 is the smallest. So we divide each one by 1.6375. Now when we do that, what we get is 3.5 moles of carbon, 3 moles of hydrogen, and 1 mole of oxygen. We cannot round 3.5. Alright, but we have to keep this ratio 3.5 to 3 to 1. So how do we get to whole numbers at this point? We're going to multiply by 2. So now our ratio becomes 7 to 6 to 2, so our formula is C7H6O2.